This video is on composite functions. So first of all, here we have a little diagram. It's got there a g machine, just a g function. X goes in, g of x comes out. So if g of x happens to be 3 minus 4x, if x now is 2, you put 2 in, what would you get out? 3 minus 4 times 2 is minus 5. But now, if it follows by the f machine, and f happens to be 2x plus 1, minus 5 goes in, negative 9 comes out. So let's put that in another way now. If x goes into g, g of x comes out. But now if g of x goes into f, what's going to come out? F of g of x. So notice that f was following g. And this is a composite function, because a composite function of f and g will convert x into f of g of x. Now how do we write composite function? Well, the textbook uses f following g of x. Now we write it in an easier way. We use f of g of x. So in other words, g of x happens first, followed by f of x. Going back to this case, the original x value was 2, so g of 2 gives us minus 5. And when you put minus 5 into f, you get minus 9. So what is f of g of 2? Well, g of 2 is minus 5, so we put f of minus 5, that's how we write it, and f of minus 5 is minus 9. So now, let's reverse the order. Let's do f first. Same x value, by the way. X was 2. 2 times 2 plus 1 gives us 5. We put 5 into g. 3 minus 4 times 5 is minus 17. So g of f of 2 is minus 17. We did f followed by g. So, does the order matter? Is f of g of 2 the same as g of f of 2? And the answer, as you can see, is clearly the order does matter, so those are not equal. So in general then, what can we say? Well, in general we can say that f of g of x is not equal to g of f of x. There might be cases when they are equal, but they are not necessarily equal to each other. In this example, we're given two functions, f and g, and we have to do certain operations. Now, the first thing that I like doing is to write f of x and g of x in that notation. And now we're able to proceed. F of g of x, I'm going to write it in that form. Now, g of x, I'm substitute it with 4x minus 5. I'll go back to my f of x. My f of x was 2 minus x squared. But now instead of x, we've got 4x minus 5. So whenever we see an x in f, we're going to put 4x minus 5 instead. Now to do the next part, a minus b squared, are you going to tell me it's equal to a squared minus b squared? Hopefully not. Certainly not equal to that. Please remember, that's what a minus b all squared is equal to. So off we go. We put a bracket because we had a minus sign there, and we expand that. We get rid of the bracket, collect like terms, and now we're done with this question. Now we move on to part B. Moving on to part B now, we're doing g of f of x. So in other words, we're doing f of x first. So instead of writing f of x now, we write down 2 minus x squared. We look at g. Whenever we see an x, we're going to write down 2 minus x squared. We expand that bracket and then collect like terms, and this question is then done. In part C, we have to work out f of x. So instead of writing f of x inside, we're going to write down 2 minus x squared. We look at our original function f of x. Whenever we see an x, we're going to put 2 minus x squared instead. Now we have to expand 2 minus x squared all squared, and just like before, a minus b all squared should give you that. Notice that next step. In the next step, we get rid of the brackets and we change all of the signs inside. We collect like terms, and this question is now done. Last example, we are given two functions, f and g, and we have to work out g of f of minus 2. We write it in a nicer way. So we have to work out what is f of minus 2. We substitute x with minus 2, we work it out, and now we can do g of f of minus 2. So instead of writing down f of minus 2, we write down minus 10, and now we work out what is g of minus 10. Whenever we see an x, we put a minus 10 instead and proceed to calculate. And this is the end of this video.